a few weeks ago, I got a really interesting email that said, all right, my um, my child is the nature thing's okay, but is really into physics, astronomy, chemistry, and these sorts of things. And how might we use nature journaling um, to both to better teach those topics, and how might we use those topics to better teach nature journaling? And I thought that this is a great puzzle and idea to set before this community. And so when there's a squirrel in front of us, we're now starting to kind of wrap our heads around the idea of like what we can do with that squirrel. But let's extend our thinking to some of these other fields, and also to the idea of when we're journaling about ideas and concepts, and making meaning in these. First of all, I'm going to bounce my screen over to the, wow, we've got quite a rogues gallery of folks on here. I think this is going to be a very, very interesting conversation. I'm really excited about kind of looks like we're kind of getting our nature journaling A team present here. So is the parent who sent me that email, are you here? If so, love just to initially kind of check in with you. What you can do is you could just mute yourself and just say, hey there.
I did send that one, but it might be many of us who did that.
Oh, great. So who was that?
This is Amy Fluharty.
Oh, Amy. So thank you so much. And Amy, maybe what we could do is we could, if you could sort of flesh out for us kind of your, kind of what prompted you to write the question, what you've observed. And so that way also our kind of collective brainstorming will also tag into those real-time needs. And if you feel comfortable with your camera on, that's fine. If not, that's fine.
Okay. My kids were all over the place, so. Okay. I have been doing, I homeschool, but I also run co-ops, nature co-ops. And so my biggest problem is honestly because I love nature and I love biology and those are my loves. But the problem is my kids are more techie, and so it's more things that I am not up on, like physics and chemistry and, kind of those areas. And so my youngest, my two other ones are gone now. So I only have one left, but this one is a little bit of more of a struggle of trying to get him in his nature journal, because I guess the pull of it's more biology, I guess, when you're out there doing nature. And I have a hard time trying to find things that would interest him, I guess. So I guess that's the biggest struggle I'm trying to find, because he loves science. That's definitely not a problem. But I want him to experience it and see it for himself and find those connections, and not just taking a textbook and saying that's the answer. You know what I mean? Because you want them to be able to make connections on their own and not just taking from a textbook. So that's my goal, is for him to be able to figure out that science on his own and not just go with it with a textbook.
Excellent.
So I can't wait to hear what you have to say. So thanks for doing this.
Amy, no, this is going to be fun. And again, looking at the Rogues Gallery guest list, I think that we're going to have some very interesting discussion here. Can I Billy Joe, can I bring you in on this? Um,
Hi.
hey there, good to have you.
Hey. Good. Good to see everyone. Yeah, we do a chemistry program at one of our sites. And so some of the things that we focus on, now this it's been a few years due to COVID and everything, but some of the things that we focus on are with chemistry are water. So looking at like maybe doing a water study with him and allowing him to really look at the chemistry of, what's going on in the water. How does that work? How do we dissolve the solids or, the gases into the water? How does that work? Or, I was just about to put in the chat, like plant structure or even poisonous plants. So there's so I'm in Canada. I'm not sure where Amy's from, but we have like cedar tea, or so it's white cedar trees that you can actually take the needles and seep them, and then it has vitamin C in it. So the chemistry portion of those tannins, sort of in it and how that works, and the chemistry behind how it can be toxic, right? We have black cherry trees which actually have cyanide in them. So it's amazing when you look at chemistry from a or sorry nature with a different eye, that you can really pull out those chemistry pieces. And I think everyone, like Amy says, we focus on the biology part of it, but there's actually so much chemistry that's within it, because we think about, what's the soil makeup, right? Like the chemicals that are in there. What is the chemical, how are the chemicals affecting nature, that humans, like what's that human impact of those things? So if he has a chemical that he's finding, interesting, or things like that, we can talk about rocks and minerals. In southern Ontario here, we have a very basic limestone is our base here in southern Ontario. So when the we had a lot of acid rain that was happening. The acid rain would come down into southern Ontario and actually be neutralized. But in the north, it's more of a Canadian Shield. There's a whole area up in one of our provincial parks that is actually quartzite. So when the acid rain hits that, it doesn't neutralize, and it actually affected a lot of our lakes in terms of them being a dead lake. What is the environmental impact? Can we bring that back? How does that work? So I just think chemistry is, there's so much that you could really pull out. I'm assuming they're in high school. I'm not sure his age, but what an amazing opportunity to then be able to document that with, numbers and graphs and all this awesome stuff, in the nature journal. And then physics, I think we look at weather, right? We look at forces of weather on structures. How are animals building those structures in order to be able to combat that? So I was really excited to hear what other people have to say for physics and chemistry today. So that's my little 2 cents on that.
That's cool. So Billy Joe, you're suggesting that we look for phenomena in nature that we're kind of aware of. There's some sort of chemical process back
Yeah.
there, and sort of in our normal thinking, we just sort of say, and then chemistry happens. Uh,
Yeah.
but then use these as a launching point to go deeper than that,
Yeah.
and investigate there. So get out there with pH test kits.
Yeah,
Um,
it's all connected, right? Like
yeah,
we, instead of looking at it being like we're doing biology and then we're doing chemistry and we're doing physics,
gotcha.
to me, when it's nature, you can't really have one without the other, right? Like you can't have the biology aspect without the chemistry that's going on inside of whatever it is, or the physics. How is it being affected by other things, excuse me, so I just think integrating all three of those sciences together. But if his focus is really into the chemistry part, then you just streamline it, and you might be surprised that the biology aspect goes like, oh, I see, like how that's connecting. And then all of a sudden, maybe they're really starting to jump on board to that, by the more specific biology parts of it too. I think you can't have your sciences without them all being sort of connected in together. That's just my thoughts.
That's really cool. So again, we're going to be looking at observable biological phenomenon that have a chemistry or a physics hook in them.
Yeah, I
And
think so.
playing with those, maybe as I'm going to encourage people to drop suggestions into the chat of phenomena that you're aware of that would be kind of good hooks for this.
Yeah, and maybe like where's Amy from? Maybe that's a great question. And then if there's someone in the group that maybe lives close to Amy, that would maybe be helpful as well. I don't know.
Amy, where are you based?
I'm in Virginia.
Oh, Virginia. Okay.
So yeah. United States and Virginia.
Yeah.
Great.
Y'all awesome. These are great.
We're just getting started.
I'm like trying to write. The reason I don't have my video on is I'm trying to write all these things and I probably look all goofy. So.
Oh, no worries at all. So let me see here. This what Billy Joe was just talking about kind of sparked a few thoughts and ideas in my head. I love the kind of the hands-on things that you can figure out. Let's start with some chemistry stuff, then let's bounce over to some physics, and then bounce into astronomy. And just with chemistry, I'm remembering there's a page, a Nature Journal page that Fiona Globally did, where she was looking at some phenomenon, and she ended up wondering what was kind of going on with the acids and bases with this. And then that bounced her out of her chair to go get some red cabbage, boil up the red cabbage, which then extracts anthocyanin, which is a pH indicator. That purple juice that you get out of your red cabbage. If you put more acid with it, it turns red, and then more base with it, it turns purple and blue. And so you can kind of push it back and forth, and she used that then as a pH indicator on whatever she was studying. Lots of plants have anthocyanins in them, and some color changes actually are mediated by pH changes in them. Let's so a couple of things to think of. We want to think of phenomena that kind of have a chemistry hook, but also then with our nature journaling practice, how do we document, how do we engage with that in our journals? Imagine that you are there, you're looking at some chemistry related stuff. You could do that without a nature journal, but what if you've got that nature journal in your lap? What specifically as a nature journaler are we going to be putting down on our pages there? Jennifer, did you or Jesse, did you either of you want to share some thoughts and ideas? That I saw you're being very active in the chat. The chat doesn't end up showing up in the recording. If I could encourage you to, can we bounce over to you, Jesse? By the way,
sure.
nice cat features.
Thank you. There's a fox, and me and my chicken get together.
Oh, yes, there we go.
She's not here anymore, but yeah, so I think that kids like to share what they learn about and be in the place of talking about it. Sometimes that's a really good way of processing what you're doing as well, and nature journaling seems to be a way of processing outside of yourself and, putting things down visually, but, you have people who have other ways of doing things with like sight and sound and stuff, and so, maybe making things on a journal is cool, but you could also do it like, what if you, either if it's something that they were learning, could show this as a poster or as a graphic on a computer, but basically boiling it down to like, what if this was like an Instagram post? How would you show this cool idea in a really simple way. And visual is really good because it goes across many languages, but sometimes that's not a person's skill set. So maybe they would want to do like a little YouTube about like, I am doing this right now, and this is what I'm, experimenting with, and I learned this, and I want you to show that I, boiled the cabbage or whatever it is, and then you guys can go back together and edit it into the simplicity that like a nature journal seems to be, of taking a big idea and communicating it in a concise way, but like taking a kid to either the place of being a teacher, or these days it's more like an influencer, is a cool way to share what you're excited about. And that way it's really guided by who that person's peers are, what their friends are excited about, because it's the same skills, but it's communicating those skills. You can start with a nature journal and then go to the mediums that they like. So that can be really cool. So that's my idea.
So Jesse, I really like what you're saying about, I'm going to just sort of pick up on two themes that I heard there. One is you're suggesting that as part of our educational experience, we can create materials to educate other people, essentially helping our children become science communicators. And then through whatever, and a neat kind of hook with that is that if they're into Instagram, great, it's an Instagram. How would you create an Instagram hook for teaching, for sharing something about this?
Yeah. And it could be science, it could be whatever it is that you're really, whatever your fandom is, and people tie science and stuff into that in all kinds of ways, but just teaching a person how to take what they like and communicate it, or to take what they like and understand it more through the skills of observation and science and stuff, and all of the things that you sort of teach through nature journaling.
Yeah, there's a neat thing that happens if you kind of can understand something to the point that you can explain it to other people. You really have to have your head wrapped around it. I really like that that thought, and I think that this could actually be a whole topic of discussion. I think sort of if we can teach people how to be science educators, the world really needs more science educators. The public understanding of science is abysmal, and the more that we identify ourselves and kind of help our children kind of wrap their heads around the being an explainer about these sorts of things, that's really, really powerful. Thank you. Jennifer, were you interested in adding to that? No.
Me?
Yeah.
Yeah, I just had put in the chat early on. Again, I'm also from the biology world, but there's a whole, like, I guess this is kind of on the theme of what Billy Joe mentioned, which is just looking for the chemistry in things that we observe in, the biological world. And as a botanist, there's a whole like world of plant pigments, and Jackie mentioned the anthocyanins and the pH indicators. And so I was just thinking about, especially with fall coming up in Virginia, and autumn colors, and that could be a really amazing time to get into like the change over time of the colors of the leaves, and maybe tying that to pigment extraction, which is really fun if you've never done it, because a lot of these pigments are in the leaves, but they're hidden to us. We don't see them because they're masked by the presence of all the chlorophyll. But when you extract them, and you can do that just in rubbing alcohol, and then stick a strip of like coffee filters work fine, white coffee filters. The pigments will travel up the coffee filter and separate out into these bands, and you can see all these different colors of pigments that were there the whole time but hidden from us. And then there's a whole world of like why they travel different distances based on the type of compound they are, and some are soluble in alcohol and others are soluble in water. There's like a whole chemistry world there too. But then looking at how
I'm just going to interrupt you for a second. Did I hear you correctly that I can make sort of a mash of some plant parts? I can soak those in alcohol. I can stick some filter paper into it. And the pigments are going to crawl up the paper, and depending on the different amounts of those, they're going to then stop in different color bands, and that will be different for different different things that I choose to crush up in there.
Correct.
Oh, you're cool.
Yeah.
Okay, I didn't mean to interrupt you,
Yeah.
but I thought that was what I was hearing, and that sounded radically awesome.
It's pretty awesome. And you know, you can also, it's really neat because, you know, sometimes you'll get colors that are just surprising. You wouldn't expect they're there, you know, like a lot of kind of a purple color in a leaf that really looks mostly green. And then
just masks so much, doesn't it?
It does. And so I think it'd be really cool to do that, say early, like let's say early fall when everything is still mostly green, but then also to go back to the same plants later in the fall after they've started changing color and look at like, some pigments are there the whole time, but they're masked by the chlorophyll, and others are produced later in the fall, and that's why you don't see them. So there's like a whole crazy cool world of plant pigments out there. So that would be really, I think, a fun thing to do. You know, you could look at the change over time, and then also kind of this hidden world of pigments.
So I could see then on the Nature Journal page, you could be first drawing that plant, trying to match colors, and making kind of a map of that leaf. Then you process it, and then you get that little filter paper. You could then put that filter paper into the journal as well once it was dry. Mm-hmm. And then repeat that on different plants or the same plants at different times of the year.
Yeah. And summer and fall are a good time to do it. When I've done it, I teach big kids, college students, but when we've done it in the spring, you just get a lot of like very spring green. But summer and fall is a really good time to do it.
Oh, that's really cool.
Yeah.
This is good. So we're going to stick with this chemistry idea a little bit more. Any other thoughts, ideas about engaging with chemistry and your nature journaling practice?
I just put into the chat. I was thinking about the I wonder questions, and then you know how we sort of break them down into 3, like let's see, could it be, and leave it be. What happens if they took some of their, you know, could it be questions, and then turn those into their own science experiment? So they designed the experiment. So not like, you know, go onto Pinterest and I'm gonna do this one, and we've talked about that before about the singing of the plants, but really get them to think like, what would happen if this happened, based on their own I wonder question. And now their nature journaling is not only, you know, using words, pictures, and numbers to describe what they're seeing, you know, adding in their data, which is their numbers, but now they're actually adding a whole new piece, which is their own science experiment, which again is going to add more words, pictures, numbers, and more, you know, questions. And so now you're taking that whole inquiry piece to a whole new level, and you're actually not only just making them, you know, an observer, but they're becoming the scientist. And then going back to like what I think it was Jen that was talking about the infographics on Instagram. Well, now you can be putting out like your findings. Like, what a cool way to integrate, you know, all of those things in together, taking that, you know, that new tech piece, you know, with your nature journal and turning yourself into an actual scientist, instead of just, you know, we say like, let's be scientists today. Like, let them actually be scientists and come up with these amazing creative ways to experiment on what it is they're seeing. I think that would be really fun. I think that would be fun as an adult. So
and so something that is cool about when you, Billy Joe, are saying let's be scientists, what you're doing, what you're starting with, they're coming up with questions, and you mentioned the could it be questions, the ones that generate hypotheses, and then on those you can do hypothesis testing. you're including them in that whole process of science, from making observations, wondering about that, coming up with testable questions, and then investigating. That's so different than if I buy a chemistry set.
Yeah.
It then allows, and it comes with instructions. Put this in with this, put this in with this. Ooh, it turned red. Isn't that
Yeah.
nice?
Yeah, but we already know what the outcome is going to be with those,
Exactly.
right? So this is like, you don't know what the outcome is going to be. And I think especially, like, again, I'm assuming Amy's son is, sort of in high school. Like, would I say, like, oh, if you're a little kid, you should definitely be mixing chemicals together and going crazy, but if you have a background and you've done some research on those chemistry pieces, and you have like a supervising somebody to make sure that you're not mixing anything that's going to be toxic, but you have a base set of information. And so again, it reminds you of, you're taking the things that you know, and you are going to decide and design your test
Right.
based on the things you know, with what you've documented, and then you're going to go for it. I mean, like, how fun
Yeah.
fun is that?
And or it kind of takes you to the place where, I do, here's the step that I'm missing. Like, I want to figure this out. How would I extract pigments? And then you can do research, and then you're finding out how to extract pigments, and then you're figuring out how to do something with the chemistry that's based on a question that you came up with, rather than one that was spoon-fed to you.
Absolutely, right. And I think that's the, for me with nature journaling, that's a major takeaway, is the not being the spoon fed. Like, you are going out to do the work, to do the observation, to be in it. Therefore, you are in the power seat of your learning. If we just continue to spoon feed everybody, then, I mean, that's what we were talking about all the time, is that we're just teaching them, how to memorize and how to do tests, but we're not actually teaching them to use their brains, right? And that, I think, is the key point to having, this amazing new generation of people coming forward, is let's teach them how to use their brain and teach them abstract thinking, that they can then go, yeah, let's think outside of that crazy box for, magical things to be happening on the other side, right? So I think that would be super fun.
I absolutely agree with you, Billy Joe. When we are just doing prefab experiments, we are not teaching our children how to be scientists. We're teaching them how to be lab technicians.
Yep.
The scientist is the one who's asking questions and figuring out what to do in order to investigate those questions.
100%.
If you feel comfortable with it, Miriam, I'd love to bring you in on this conversation. Miriam is a nature journaler and fire ecologist and researcher, and you've been dropping some bombshells over in the in the chat, and I think it really kind of ties into this beautifully.
Yeah. So yeah, I think it's hard to know exactly chemistry or physics, but there's a lot.
This will then be our bridge to physics.
Okay. Yeah, I think that there could be a lot of opportunities with fire, even something just a campfire, or if you had a few materials in a safe little sandbox or something that you were burning. But there you can observe the whole process, the pyrolysis, when it's early, just heating up in the wood and seeing the steam come out, with a mix of senses, from the smell, from what you see, from what you hear. The color of the flame can tell you a bit about the temperature, and you can just a whole amount of things. Where the flame is attached, how it's moving, has a lot to do with the process. Those are all observable. The color of the smoke can be different depending on what it's burning. Not just amount of moisture will change how much white and steam is mixed in with it versus darker. But if there are a lot of other, if there are copper elements or things like that, it'll change the color of the flames and the color of the smoke as well. So I think there could be interesting things with observing flame. There's also just even fire in general on the landscape, on observing the changes in moisture and how things would burn. So different leaves based on the shape of the leaves, based on how they're arranged, how dry or moist will change fire behavior. So there's a lot of observable things to look at within the whole fire world.
That's really cool. And also that brings us into the whole idea of carbon cycling. There's this, when you burn the match, you end up with less material than you had before sitting there in your hand. Well, where did all that other material go? Bunch of it went into the air. And then there's the other question of where did it come from? The crazy thing is, like, everybody thinks like there's this wonderful experiment that was done where people took a little plant and they grew it in some soil and they watered it and they watched the little plant grow. They had measured and weighed the soil before, then they measure and weigh the soil after. Eventually the plant grows up big, you take it out, you completely dry it out, so all the water is out of it. And you shake all the dirt off the roots, and then you measure, the amount of dirt that you had before, the amount of dirt that you had after. It's the same. And then, well, where did all the stuff in this tree come from? And most people, you ask them that, and they'll say, well, it came from the soil. But there's actually the same amount of soil. Oh, then it came from the water. So there's stuff in here that's not, where did this water, where did it you can figure out that it's not the water. And the wacky thing is that, I'm gonna ask everybody to, without hitting send on the chat, write where did all that stuff come from into the chat, and we'll all dump it in at the same time. So everybody on there, you're going to write, where did the mass of this tree, the stuff that is making up the mass of this tree, where did it come from? You ended up with the same amount of soil. And hit send. That's right. So when I or a tree falls down in the forest and it rots, it decomposes. Everybody says it's going back into the soil. But for several reasons, this isn't right. It turns out it didn't really come from the soil, because remember, in that little pot, you end up with the same amount of soil. So if you got this thing and if it all came out of the soil, well, and you've got the same amount of soil, you can't get something from nothing. It turns out, people are seeing it in there, it's the air. Carbon in the air goes into the plant in the process of photosynthesis. So it's taking carbon out of the air and putting it into the plant. The plant is made, that tree out there, made out of air. What? Yeah. And then when it decomposes or it burns, where does it go? People say, well, back into the soil. But you can actually measure the amount when the thing's totally decomposed. That's not where it's going. Maybe a few little sort of trace nutrients kind of went up in the tree and then decomposed and they go back down. Yeah, that one's going to go back in the soil. But the mass of that thing that came from the air, it's not going back into the soil because it didn't actually come from there. It's going back into the air. And the same thing happens when it burns. So Miriam, you've got sort of a way there of also kind of engaging people with this carbon cycle. And the, it is, this whole kind of idea of like, where does stuff come from? Like the carbon cycling, it's totally counterintuitive, because I grew up thinking like, the tree came from the soil and it goes back to the soil, up from the soil, back from the soil, right? Nope. It's out of the air. That's some nuts. But understanding what carbon is and what carbon does is now more and more and more important as we're thinking about atmospheric carbon for all sorts of different reasons. So the burning stuff that you do, Miriam, there's lots of interesting links with that. I thought of one other kind of example of a chemistry thing. I was just up in Yosemite in Tuolumne Meadows, and up there are these rings of grass. So grasses that grow in the meadows will grow out in a ring, and there'll be a big bare spot in the middle. And I was talking with one of the interpretive naturalists there, the chief interpreter, like, so why is that? What's going on with that? We're doing all this, I wonder. And we realized that we didn't know. But what we then wanted to do is to kind of get some soil test kits and test the soil nutrients on the outside of the circle, on the inside of the circle, and right on the edge where the plants are. We're wondering if, as this plant is growing, it's kind of not very nutrient rich soil. It's recent kind of, granite chuff. And what a nice opportunity to use the word grus. And so we're wondering if, as it's getting bigger, if it's kind of carrying the nutrients along with it. We didn't know, but that would be something that we were both thinking, like, ooh, that would be really kind of, if we got to get some little, and maybe it's not happening with all nutrients. Maybe there's one kind of key nutrient that's actually being moved along, or maybe there isn't. Because as Billy Joe was talking about the kind of hypothesis testing, we always say, well, it could be this, it could be this, it could be this, it could be this, or it could be something else that I just haven't thought of yet. And you always want to kind of keep that possibility in mind. Now that we're burning things up with parental supervision, I'm here in a part of the planet with a very high fire danger. And so let's just be cautious of how we do that. But fire is not something to be afraid of. It's a natural process. And actually thinking about that and including it in our lessons I'd say is a very good thing. What are some other kind of fun physics phenomena and ways to document them in our journals? I'm going to go over to the gallery here. You can just start talking or raise your hand and I will spotlight you. Maybe I'll get us started here. I was looking at a stream, and in the stream there was a standing wave, and it was a very clear stream, and but there's this little standing wave. It was actually kind of like a coxcomb, almost like a shark fin sticking up in the middle of the water. The water was rising up in this little bulge in the middle of this stream, not just a bump like it was going over a rock, but it was actually in this little coxcomb. And I was thinking, like, what is going on there? And my friends were delayed. The people I was going to be meeting at this trailhead, they were delayed for about an hour, and I had this time to play with that. And I started then sprinkling little bits of leaves upstream from it and watching those leaves come down and see how they moved across this little coxcomb. Then I was realizing that wasn't getting me what the water motion was doing underneath it. And so I started to put in sort of little fine pieces of sand that wouldn't sink too quickly, that I could see kind of go through this and sort of tracking their motion through it. And I was absolutely fascinated by this little shark fin standing wave. And I came up with, in my journal, several different possible explanations of what it could be. So on the bottom of my page, I had, like, it could be doing this, or it could be doing this, or maybe it's because of this, maybe it works this way. And then I was able to cross off a few of those by sprinkling my things in, because those were dependent on the water underneath moving in a specific way. I was able to figure out that the water wasn't moving that way, and just had a ton of fun with these fluid dynamics. Just the other day, I was looking at Walters, help me out here. What is the name of those kind of kiteboard things where you're not really kiteboarding, but there's a wing underneath the water? If Walters is still with us, you're here earlier. There was people were doing this sort of windsurfing thing, and on the bottom of the windsurfer, there was this big keel that came down that had a wing attached to it. And I was a waterfoil. So I was looking at these kind of the structure of the waterfoil, and then trying to think about like trying to remember what I knew about Bernoulli and what could be going on with this to allow these water foil people to be kind of elevated above the water on this little wing and just whipping across this lake where I was making my observations. That's all physics. And it was, you know, what's the last time I really thought deep about Bernoulli? It's been quite a while, but there I was out with this little phenomenon. What are some examples of other sort of physics phenomenons that I see people have? I'm going to encourage people to add it into the conversation. Oh man, the chat is blowing up right now. Would anybody like to share some of those ideas in the conversation? All you have to do is you can unmute yourself and then you can start talking, or just raise a hand and I will bounce over to you. So Debbie's talking about pollen flying through the air, thinking about sort of visualizing the motions of air. When you're looking out and you see an inversion, you're looking at, you know, particles in the air allow us to see this kind of the fluid of air that's all around us. You know, sort of imagine you're in this big air sea, but we normally can't see its motion. The pollen allows us to see that. Other things that allow us to see the motions of air, sometimes how smoke drifts. When there are fires, you can sort of see inversions where there are temperature gradients. Clouds and weather. Clouds are another indicator of the motions and the physics of air, and documenting those in our journal. Perhaps here's the cloud, and here's, you know, what do you think is going on inside that thunderhead? I know in the past I've seen some diagrams of that. I wonder what data those were based on, and what that looks like. Are there any other physics phenomena? Chris, thank you.
I grew up near the Wedge in Newport, Balboa, and studying waves and the relationship to the currents, predicting what's going to be a really big surfing day and what's going to be safe was a very important thing to know, and it's a lot of physics.
That's
something that could interest kids, I think, even if they're not near the seashore. There's a way to just study waves and currents, directions. Yeah.
Waves, currents. I've done a lot of sort of nature journaling waves, and where I've got little arrows sort of showing like when they're kind of coming in low. And you get this, you know, this is what the foam does, and when it comes up and high and crashes, it makes this other different kind of, right? Sort of paying attention to those things. I think that would be fantastic to additions to a journal.
There's the bottom, the shape at the bottom, and the wind on top work together in ways that are sometimes predictable.
That's right. Yeah, so what is the relationship to where you see the wave break and the shallowness of the water? So if you're out at a coastline where it's safe to do so, walk out through where the waves are breaking and notice, sort of figure out like how deep it is, right? And where the waves, you know, is there, can you figure out for the energy of the waves that are kind of coming in on that beach where you are, what is the depth at which you start to see the wave mounting up? What is the depth at which it breaks? Those are cool relationships. Is there anything else in this area that kind of
There's a connection between the ocean currents and studying biological forms and where certain plants and animals have ended up on which continents because of the currents. I know I spent a lot of time sailing in the South Pacific, and you know plants and things have ended up on certain islands in certain areas, and it's fascinating. In some cases, you couldn't possibly predict it, but it really is a whole area of connection of physics and biology.
Oh, that's really cool to think about. And as ocean currents are now becoming much more important things that people are thinking about in terms of global climate.
Yep.
And those global wind patterns, the physics of that is fascinating. Basically, it's fascinating. Like if you're heating up the equator, air is going up. Well, if air is going up, where's other air coming in from? Well, you get a little convection cycle. That means it's coming down somewhere. So where it's coming down, what does that mean for the conditions, right? And then as you kind of roll up the globe, there are all these things that you've heard of, the westerlies, the doldrums. The doldrums are part of this whole kind of global air cycling thing. And then you have to throw in a spinning planet underneath that. And really, really cool things happen. The jet stream, so the location of the jet stream is all tied into these same patterns. The physics behind that is so cool. And it has, so rather than, there's this thing called the jet stream, but you kind of dig deeper into like what's going on with that. And it's tied into these sort of worldwide circulations of things. And it's stuff that kids can wrap their heads around.
They can. And it also can help understanding the Pacific Gyre, where all the plastic and stuff is ending up, and why it's accumulating there. Yeah.
Oh,
sorry, I don't have much voice.
Well, thank you for using what voice you had to drop those ideas on us. I'm going to bring in Jennifer back in on this. And what are ways which we might be able to really start geeking out more with physics in our nature journal?
I just had one idea I put in the chat, and another one about birds, which is observing raptors like moving up on thermals when they're, it helps them, they don't have to flap as much because they can ride these currents of air moving upwards, and then they can soar further. So it minimizes how much energy they have to put into moving around, which is pretty awesome to see. So you'll see these just groups of vultures, especially, but other raptors too, sometimes spiraling around and moving up in these currents of air, which is really cool because it's like they're moving up, but they're not flapping their wings. How are they doing that? And then another one, if you, Amy, were able to come across, if you ever come across owl feathers, that owl feathers have these kind of adaptations that when you flap it up and down, it's silent compared to, say, like a hawk feather. And so it's just the physics of the way the feather is shaped and the way the air moves through the little, pinny on the feather is a really cool example of physics and adaptations of those owls. So there's a couple more physics and biology.
That I love. Those are great examples. And you sort of bringing up that spiral also ties us into to the whole idea of patterns in nature. So when there are specific types of patterns that are very often related to similar sort of causal phenomena. For instance, spirals are often associated with growth. And so you look at that, say the nautilus or the snail shell, that spiral, it's a growth thing. And it doesn't necessarily mean it's growth, because there can be other sort of phenomena that are going. But when you kind of identify these patterns, cracking patterns for kind of distributing energy, explosion patterns for distribution of things, meanders, the physics behind stream channel carving is fascinating. Actually, hold on, was just looking at, it's book time. I was looking at a stream meander in Yosemite and looking at erosion happening with that, where you get the depositional bars and the erosional bank. The physics behind that and the physics behind the hydrology of streams, kind of the riffle pool pattern. Anybody who goes fishing kind of knows, as you walk down streams, you're going through the riffles, you get to the pool, go through the riffles, get to the pool. What is the relationship of those and water velocity and the size of the stream and what's going on with the meanders and the substrate? Those are all really cool things that you can, in the physical world, kind of geek out on, and that's more physics.
Yeah. Also patterns of the way that you know, pebbles and stones and sediments of different sizes settle out differently depending on the flow of the water. Be another example.
That's right. So you know, when you see a little place where a stream channel has come down and then it's kind of washing out on, say, an alluvial fan on the base of a big mountain, or a little tiny alluvial fan where you see a little creek coming down, and kind of a little ephemeral creek that came out during the last rain and distributed a little bit of sand on the edge of the road. The physics behind those is very, very similar, and they're invitations to investigation. Let's bring Billy Joe back in and spotlight. There we go.
So just going off of this, in my previous life, I used to do a lot of whitewater canoeing. And so that is in the rivers. And so the whole hydrology of the river and how that works, right? And so I was just like, had this thought of like, how amazing would it be to like, you know, if you were into whitewater canoeing, it's amazing the physics that are a part of that. But you know, they could measure, potentially look at the geology. So now we're bringing in geology to it, is like, how steep is that original drop off, and then where does it bank, and then how high are your standing waves, what's happening to stretch the water molecules to push them back up, how long is that train before they start to peter down, you know, how is a hole created, you know, and what is the geology of what's happening underneath that river that is affecting the geology. So taking in, you know, your stream parts, you know, why are eddies created? Why are they not? What is that line where that, and so if anyone doesn't know what an eddy is, it's where the stream bank comes around and the river flows. But the eddy, the water actually flows backwards. So it's actually going upriver, which is insane when we're thinking about that, you know, how that's moving past one another, you know. I just brought me back to my early 20s of whitewater canoeing and having a lot of fun and sitting around and then picking a route, right? And how to pick a route through all of those things to get to the bottom of the river. And then, yeah, that same thing, that pool and drop. You know, we have that, a lot of that in Ontario. You get a set of rapids and then it pools out. But when I was in Costa Rica, there was no pool and drop. The river was a continuous flow. So how do they differ between each other, right? There was no big pools. Like in Ontario, it's very like, you get a drop and then you get a pool, and then you get a drop and then you get a pool. So we were whitewater rafting in Costa Rica, and I flipped out of the boat anyways. And I was like, oh, I'm going to make my way to Nicaragua if I don't figure this out. So, you know, it's, you know, it's interesting when you think about the hydrology of the place that you're in, but then what would that look like somewhere else, you know, to be able to sort of, you know, match those things. Anyways, I just thought that was pretty cool. So that inspired me for some stuff there. So I just think that's pretty neat.
And as we're all getting to know each other in this forum, I should have thought to myself, of course you were a whitewater rafter.
Yeah. It's really
Yeah,
fun.
have you ever had one of those fun places where you can jump in and you go down with the ripples, then you get caught in the eddy, and it brings you back upstream, and then you get to go down it again, and you can just sort of play. And
Yeah.
does anybody during
Yeah.
it?
Yeah, so I've only rafted once, so I've only ever canoed. So that's two people in a tiny boat in these, massive rapids and stuff. So yeah, like if you can pick your route, you can eddy in, eddy out, you can surf with a canoe as well. So, going back to what Chris was saying, what is that river looking like in the spring? What is that river looking like in the fall? And how is that water different with the different water levels after a snow melt, after a rain, all these sorts of things. And really depending on where you live, I mean, I'm super lucky up here, right? We have lots of water. There's wherever I look, there's a lake or there's a river, there's something around here. But, if you have that in and around your space, what an amazing place to be able to go and look, and how they work. And, I think that same thing about the erosion with the streams and the rivers cutting out. I used to canoe trip quite a bit, so you'd be able to see that depending on where you are. And if you did that same route over and over year after year, you'd be able to see, like, why is the tree falling down, like how does that happen, all these different sorts of things, just with like river morphology, right? Like,
Yeah.
how cool is that? Yeah,
That's
that's pretty amazing.
wicked cool. Yeah,
We are nerding out on all new levels today, I just have to tell you.
no. But that's what. But
I love it.
This stuff is so much fun.
So
And see,
great.
what I love is that you brought in the sport aspect of it.
Yeah, because some
Because-
people, because that's, for me, physics was never my thing either. But then I got into canoeing, and then I was like, oh, physics makes sense to me now.
Yes.
Right? When I put my paddle in the
Wait,
water.
hold on. Just say that again. What you just said, say that again.
Yeah, so physics wasn't my thing until I started canoeing, right? And then I was like, I get it. Because I am a person who needs to do in order to get it. So someone just saying this force against this makes this do this, I go like, that's over my head. You put a paddle in my hand, you stick me in a boat, and I go, oh, I get it.
Yeah.
Thank you so much. I get it. Right. So yeah, if you have kids that are into sports and you're now teaching, like, get them on the water in some kind of way, build boats, build little rafts, do all these things. Now your journal again is your process. How are you doing it? What are you observing? How are you changing it? Your journal becomes this incredible tool that is integrating all these different things. You're outside, you're active, you're thinking science, you're documenting it, you're getting your math in. Like, honestly, like, it's just done. Thanks. I just think it's so cool.
And so just so you can be out there, as I think it was Ratty in Wind of the Willow said, there's nothing in this world half so much worth doing as simply messing about in boats.
Yeah.
Right? And so you can be out there just messing about in boats, but not really thinking about the physics of it.
Yep.
But if you then decide, all right, I'm going to try to make a diagram. Why does the sailboat go this way when the wind is coming this way and my sail's like that? Right?
Yes.
Can I, if I can take this physical experience that I'm having, the play that I'm doing, think of how many sports that every sport you're thinking about, there's kind of this physics that's involved, that's behind the scenes.
The Olympics are on right now. Honestly.
You mean the display of the physics demonstrators?
Yeah.
From the world has gotten their physics teachers.
Yeah.
From the best physics teachers from all these different countries to come and put on displays of physics for us.
Yeah. Where the rest of us go, what? How is that humanly possible? Because of physics.
So, but then if we can get ourselves to make the diagram to try to explain it to ourselves, we're then taking this physical hook and using that to kind of push us on to the next level.
Okay, so this I think is key. So I was listening to Beth Ann Burton, one of her podcasts today, because I'm like in love with them. And somebody was talking about it was a friend of hers. Oh, you'll have to forgive me, I can't remember his name. And he was a teacher at the Waldorf school, and I believe Fiona is a Waldorf student as well.
Yes.
And that's new. I've never heard of this before. But they were talking about like just the body, right, and learning about the bones and the muscles and things like that. And in the Waldorf school, they said you have to draw that so that you remember it, right? And so I always think like teachers sometimes they print things off and say just label it, and you'll remember it. But that doesn't work, right? Like that, we know that doesn't work. So imagine if you're watching Simone Biles, let's say everybody knows who she is, and she's on the beam, but you are nature journaling her tumbling. Now you're getting it more than just observing it or someone giving you a print off of how to do, a back handspring or whatever it is. Like, it's no different than if you are journaling an animal running. Why can't we talk about how they are moving in through the air and what that looks like? Again, it doesn't need to be a pretty picture, but we're looking at and we're calculating how that sort of moves and rolls. And now you're making, again, a personal connection, because maybe you are a gymnast, maybe you are a dancer, and you never realized before the physics that is involved in what you are already doing. So I just think that's pretty neat.
That's awesome.
Mm-hmm.
And so if we can then distill this down to a basic techniques, and we haven't even touched astronomy here. We're gonna have to save that for an upcoming workshop. I'll get it on the calendar. We're gonna do astronomy, and we might want to come back to this because just looking at the chat, this is such a rich area. So the general practice is start with what am I observing? So if you're showing this gymnast going through the air, make a diagram of what happened. You don't have to worry about why yet, but just start with documenting. I'm noticing the water comes down here, bounces off of this, and then it's recirculating here. Then, with giving yourself permission to be wrong, try to come up with 2 explanations of why that might be happening. The reason we're putting in 2 is just so we don't assume that the first one which we get is correct, right? But document the physical event, and then why, right? I'm thinking that, and then you're thinking like, I think that water works like this is coming off here, that's then hitting the rock on the bottom, that's then pushing up, and that's what's making the coxcomb here. Whatever it is, you put in your explanation of, and then just label that, I think, or could it be, or perhaps, that qualifying tentative language, so that we are keeping a distinction on our head from what we observe, our data, and our explanations. The what and the why are very, very different things. But as a process for this in your journal, start with the what and then bounce into the why and see what happens. There's one other thing that I want to, it's just not fair to drop this on you folks at the end. But before this talk, I was thinking, well, just in case there's a lag in the conversation, which I should know better, it's not going to happen with this crew. I just did a little search, and it came up with some very, very interesting things. So I'm just going to bounce over to my Google searches. So we're going to now just a little bit of Googling with Jack. And here we go. There we go. Wait a minute. What is going on here? I didn't expect to see this. Were you looking at my Wells Fargo thing there? No, it wasn't. All right, let me see. I'm going to go here. Let me see. Okay, I think I can get it this time. Let me try this one more time. And here were my Googles. Right, so I said, what I was thinking about is like, we're observing phenomena, and then what we want to do is come up with some ways of diagramming these. So I was just looking at, for people who are doing quantum theory stuff, how are they visualizing explanations in diagrams? And like I was thinking, like, oh, there are these cool, like these you know, like, what on earth is a blotch sphere, right? It's a way that they have of visualizing information, and I have, like, it's a visualization tool that they're using that is not in my vocabulary, my mental vocabulary. I thought that's interesting. Like this little one over here. You know, like, what are you thinking about as you are kind of generating this little network? There are some sorts of diagrams where I kind of go like, oh, I think I understand, you know, why you know, how you would make a diagram like this. But then it made me realize that there are other diagrams where they're intentionally using, like when they're using a diamond, when they're using things, there's a lot of people who've put a lot of thought into diagramming different sorts of things. It is fascinating just to look up diagrams for diagram's sake and think about the implications of that for visualizing a phenomenon, right? And so then, you know, here are diagrams in astronomy. How are these people who are kind of setting out to sort of play with these things, how are you visualizing phenomena? And what it really made me get excited about was, you know, so these are explanations. Oh, this is cool. This is the Wikimedia Commons for specific diagram types. So again, why am I kind of getting into diagrams here? I'm getting into diagrams here because these are tools for visualizing an idea. And it just made me realize that in the area of diagram theory, I think this is an incredibly rich area for us as visual thinkers and nature journalers to explore. When do we use a tree diagram versus a cluster diagram? And what is the difference in the usefulness of those things? When do we use a timeline versus a spiral diagram? You know, what, you know, I mean, that's like, what are you saying? What are you showing? I want to be able to get myself to be fluent with more of these styles and approaches to visualizing information. So those are the general diagram types. But look at this. Here's general concept diagrams, the difference between an activity versus a comparison versus a decision versus an explanatory diagram. See, I think that if we nature journalists do a little bit of behind the scenes geeking out in diagram theory, I think we can come up with some crazy, crazy stuff. How are they used in systems engineering? How are they used in entity relationship diagram? I don't even know what you're talking about. Isn't that great? Isn't that great? I mean, this kind of thinking about types of diagrams, like I'm seeing, like, oh, there's a Venn diagram, but that looks a lot like a Johnston diagram. But for some reason, people who are thinking about diagrams have said, like, well, this is different for these reasons. That means, friends at home, they're using these for different purposes. And messing, if we kind of can grok some of this stuff, we have just amplified the toolkit that we have for visualizing some of these ideas. So this ties into, you can look at like what kinds of visualizations are happening in chemistry, which ones. And when I looked at the chemistry ones, they were not as creative and varied as the ones that were going on in physics. So, and so this means that there may be like a whole area of visualization that that people haven't even unlocked yet. So I want to encourage you folks to let's think about nature not just as the squirrel, but nature. When I use the term nature, I use this as sort of as opposed to say supernatural. So things that are the supernatural, you cannot measure, observe, quantify. But anything that you can measure and observe or quantify, that is, in terms of scientific parlance, this is the natural world around us. And if we can observe it and mess with it, you know, we can bring our nature journaling toolkit to bear on it to understand it more deeply. And so I want to encourage you to not just think about the squirrel, but think about the standing wave in the river. Think about the pattern that you see that has of the eroding silt out of the corner of your garden, right? Or the angle at which the snow has piled up around the building, or the patterns that snow makes as it melts. There are observable, measurable phenomena of physics, of chemistry, of the way that the world works that are sitting there in front of us for us to play with. So not just, there's a beaver, I'm gonna draw the beaver, right? I want to start thinking about like, oh, and sort of downstream when when that washed out, it created all this sort of crazy erosion stuff here. That is this little window into the physics. And you say, but I don't understand. Let's say I didn't take physics in school. That's okay. It's totally okay. Geek out with it, mess around with it, see what you can learn from it, and just say, could it be perhaps this? You don't have to use other specific terms. You can make up your own terms. And there's this whole crazy world out there of phenomena for us to explore. And I think we can have a ton of fun with that. I want to thank all of you for being here. I think that we have tapped into a subject that is going to be very, very, very worthwhile for us to explore more. I also want to encourage everybody here to mess around a little bit with diagram theory and see if there's like, if anybody can understand, like, you know, I actually really like Johnston diagrams, and I think I'm going to use them, you know, for this. Can we figure out? Let's see what we can do, and we'll have a future educator workshop about astronomy. We'll have a future educator workshop about messing around with just diagrams and visualizations, right? Before we wrap, is there anybody else that would like to drop a nugget of wisdom on us? I want to encourage people to save the chat from this and take a look through that if you haven't had a chance to do that. You go to the chat, so click on chat, the chat box pops up on the bottom right-hand corner. There's a little ellipsis, 3 little dots in a row. You click on that and it says save chat. Bing. Hit save chat, and all those good ideas that people were dropping in there are now saved on your computer. It's a beautiful world, and the more that we can geek out on it, the more that just opens up to us. And thank you all for being here, and thank you for sharing, and I look forward to seeing you all again soon. I'm going to just drop back in with at the start we heard from who was was it Debbie? Were you our original instigator in this? No, if that
Oh, your sound is a little bit strange. It sounds like there's something in front of your speaker.
Am I better now?
Yes.
Okay. I can't fool you guys with that anymore, can I? No. Yeah, I looked over. She was like, no, you're not going to get me again with that. So, hey, everybody. Thank you all for being here. Thank you so much for these great ideas, and happy journaling.